Next, we are going to see some useful results. First result, the equation of the circle passing through three non-collinear points x1, y1, x2, y2 and x3, y3 is determinant x1, x2, x3 first column, y1, y2, y3 second column, 1, 1, 1 in the third column into x square plus y square plus next determinant first column c1, c2, c3 second column y1, y2, y3 third column 1, 1, 1 into x plus third determinant first column x1, x2, x3 second column c1, c2, c3 third column 1, 1, 1 into y plus last determinant first column x1, x2, x3 y1, y2, y3 second column third column c1, c2, c3 equal to 0. This is the condition for 3 points are collinear, right? So we'll see the proof. Let the equation of the circle passing through the three non-collinear points x1, y1, x2, y2 and x3, y3 is x square plus y square plus 2gx plus 2fy plus c equal to 0. That is equation number 1. Since 1 passes through x1, y1, x2, y2 and x3, y3, these 3 points will satisfy the equation 1. So that means put x is equal to x1 and y is equal to y1 in 1. So you will get x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. That is equation number 2. Similarly, put the other points also. So put x is equal to x2 and y is equal to y2 in 1. We will get x2 square plus y2 square plus 2gx2 plus 2fy2 plus c equal to 0. Third equation. Then put x is equal to x3 and y is equal to y3 in 1. Then last equation x3 square plus y3 square plus 2gx3 plus 2fy3 plus c equal to 0. Fourth equation. Let 2g is equal to a and 2f which is equal to b. c1 equal to minus x1 square plus y1 square and c2 is equal to x minus x2 square plus y2 square and c3 equal to minus x3 square plus y3 square. So in order to solve this equation, just we are taking like this, right? So this equations 2gx1 plus 2fy1 plus c equal to, right, minus x1 square plus y1 square. So 2 implies we are taking the second equation, keeping 2gx1 plus 2fy1 plus c equal to 0 one side and minus x1 square plus y1 square to the other side. So we are going to form 3 equation. We are going to rewrite this 3 equation 2, 3, 4 into 3 equations in order to make it as a determinant, right? Because x1 square, y1 square all are constant, so adding these 2 is also a constant. That is why we are taking c1, c2, c3, constant 1, constant 2, constant 3, right? 2g also a constant, 2 into some constant, that is a. That is why for our convenient we are taking like this, right? This becomes ax1 plus by1 plus c equal to c1. So we will get a standard equation, right, like that. Similarly, that is equation number 5. Similarly, other 2 equations, 3 implies, so you will get ax2 plus by2 plus c equal to c2. That is 6th equation. And 4th equation implies ax3 plus by3 plus c equal to c3. That is 7th equation, right? We are going to take delta, right, determinant value of first column x1, x2, x3, y1, y2, y3 and 1, 1, 1, right? That is equation number 8. Since x1, y1, x2, y2, x3, y3 are non-collinear, delta not equal to 0. Non-collinear point, right? Here not collinear, non-collinear point. That is why delta not equal to 0. That is the standard result we are having, right? So now c1, c2, c3, y1, y2, y3, 1, 1, 1. We are taking this determinant which is equal to substituting the value of c1, c2, c3 from the last 3 equations, right? ax1 plus by1 plus c, ax2 plus by2 plus c and ax3 plus by3 plus c from the equation 5, 6, 7, right? y1, y2, y3 second column, and 1 1 1 in third column, right? So we are splitting into three determinant. First ax1, ax2, ax3 first column, then second column y1, y2, y3, and 1 1 1. We can split like this. We know determinant property, so that is why we are using that property and splitting. Then second term plus by1, by2, by3, y1, y2, y3, 1 1 1. Then last column plus last determinant plus c in the first column, y1, y2, y3 in the second column, 1 1 1 in the third column. So now we are taking using the property. So if any element is common in one row or column, you can take it outside, right? So we are taking a outside, so we will get first determinant x1, x2, x3 in the first column, y1, y2, y3 in the second column, 1 1 1 in the third column. Similarly, b is common in the second determinant, so take it outside. So b into y1, y2, y3, y1, y2, y3, 1 1 1, plus c is common in the last determinant, take it outside, 1 1 1, y1, y2, y3, 1 1 1. In a determinant, any two rows or column are identical, then the value of the determinant is 0. See here, b into that determinant, y1, y2, y3 first column and second column are equal, so value 0. In the last one, c into that determinant, 1 1 1 in the first column and the last column also, so identical, therefore that value is also 0. So you will get a into first column x1, x2, x3 determinant value, right? y1, y2, y3, 1 1 1, right? So now next we are going, this implies c1, c2, c3, y1, y2, y3, 1 1 1 is a into this value is delta, we have keep it as delta, right? So a into delta, so eighth equation, that is right. Now a is equal to, a value is equal to determinant c1, c2, c3, y1, y2, y3, 1 1 1 by delta. So a value is nothing but 2g, a is 2g, right? So 2g is equal to, a is equal to c1, c2, c3 determinant value y1, y2, y3, 1 1 1 by delta. That is equation number 9. Now we are going to consider next determinant x1, x2, x3, c1, c2, c3, 1 1 1. So substituting c1, c2, c3 values, right, from equation number 5 6 7, right? x1, x2, x3 first column, second column ax1 plus by1 plus c, ax2 plus by2 plus c, and ax3 plus by3 plus c, then last column 1 1 1, right? Now we are going to split the determinant into 3. So first determinant x1, x2, x3, ax1, ax2, ax3, 1 1 1 plus x1, x2, x3, by1, by2, by3, 1 1 1 plus third determinant x1, x2, x3, c, 1 1 1. So we are using we are going to use the properties of determinant. So in the first determinant, a is common in the second column, so take it outside. So that becomes x1, x2, x3, a into x1, x2, x3, second column x1, x2, x3, third column 1 1 1. This is the first determinant. Second determinant, take the b outside, so b into x1, x2, x3, y1, y2, y3, 1 1 1. In the last determinant, third determinant, take c outside, so taking c outside, you will get c into determinant x1, x2, x3, 1 1 1 1 1 1. In the first and third, see, first column and second column in the first determinant x1, x2, x3 are identical, so that value is 0. In the last determinant, c into that x1, x2, x3, second column c, 1 1 1, and third column also equal, so that value is also 0. So you will get b into x1 determinant x1, x2, x3, y1, y2, y3, 1 1 1. So determinant x1, x2, x3, y1, y2, y3, 1 1 1 is delta, right? So b into delta, right? Therefore determinant x1, x2, x3, c1, c2, c3, 1 1 1 is b delta. Therefore b is equal to determinant x1, x2, x3, c1, c2, c3, 1 1 1 by delta. But b is equal to 2f, right? So 2f is equal to determinants x1, x2, x3, c1, c2, c3, 1 1 1 by delta. This is equation number 10, right? Next, now we are going to find the value of the determinant Determine x1, x2, x3 first column, second column y1, y2, y3, third column c1, c2, c3. Now we are going to substitute the values of c1, c2, c3 again here, right? So the determinant becomes determinant first column x1, x2, x3, second column y1, y2, y3, third column ax1 plus by1 plus c equal c, then ax2 plus by2 plus c, and third column third element ax3 plus by3 plus c, right? We are using the equation 5, 6, 7. Now we are going to split the determinants into 3, right? So first determinant x1, x2, x3, y1, y2, y3, ax1, ax2, ax3. Second determinant plus x1, x2, x3, y1, y2, y3, by1, by2, by3. Plus third determinant x1, x2, x3, y1, y2, y3, c, c, c. The first determinant you can take a outside. See the third column ax1, ax2, ax3. So take a outside. So you will get a into x1, x2, x3, y1, y2, y3, x1, x2, x3 again. Right? Here also two columns are identical. First column and third column. In the second one, b is common in the third column. So take it outside, b into x1, x2, x3, y1, y2, y3, y1, y2, y3. Again, here two columns are identical, second and third. Last one, x1, x2, x3, y1, y2, y3, c is common, take it outside, c into x1, x2, x3, y1, y2, y3, 1, 1, 1, right? Right, so we will get c delta, right? We are using equation 8. Therefore, so x1, x2, x3 determinant y1, y2, y3, c1, c2, c3 is equal to c delta. Therefore, c is equal to determinant x1, x2, x3, y1, y2, y3, c1, c2, c3 by delta. This is equation number 11. Now from 1, 9, 10 and 11, the equation of the circle passing through non-collinear points x1, y1, x2, y2 and x3, y3 is x square plus y square, substituting the value of 2g, right? Determine c1, c2, c3, y1, y2, y3, 1, 1, 1 by delta into x, plus substituting value of 2f, determine x1, x2, x3, c1, c2, c3, 1, 1, 1 by delta into y, plus substituting the value of c, determine x1, x2, x3, c y1, y2, y3, c1, c2, c3 by delta equal to 0 by using the equations 9, 10, 11, right? So just to take the LCM, delta as the LCM, so delta x square a plus delta y square plus determinant c1, c2, c3, y1, y2, y3, 1, 1, 1 into x, x1, x2, x3, c1, c2, c3, 1, 1, 1 into y, and x1, x2, x3, y1, y2, y3, c1, c2, c3, which is equal to 0. So delta is common grouping, because whole divided by delta, delta into 0 on the right hand side, you will get 0. So there will be no denominator in that case, right? So taking delta common, delta into x square plus y square plus c1, c2, c3, y1, y2, y3, 1, 1, 1 into x, plus determinant x1, x2, x3, y c1, c2, c3, 1, 1, 1 into y, plus determinant x1, x2, x3, y1, y2, y3, c1, c2, c3 equal to 0. We know delta value is determinant x1, x2, x3, y1, y2, y3, 1, 1, 1, substituting that into x square plus y square, then all the remaining terms, which is equal to 0, which is to be proved. So this is the condition for 3 points are non-collinear, right? Thanks.